Okay. Hello, everybody, and welcome to episode 7 of MakerBot Chats. My name is Felipe, and yeah, for the last couple of weeks, 8 now, we've been hosting these casual conversations where basically we look forward to hear your questions about all of our platforms. We've been focusing heavily on the method, of course. We do new materials, we review some of the printer's features. But yeah, it's really exciting to be with you guys today. Today it's going to be a short one. It'll sort of work as a follow-up of last week's episode where we introduced Method Carbon Fiber Edition. That was really exciting to talk about. Of course, there was not enough time to cover all of the questions. We've been having some other questions as a follow-up, gathering them through social media and through email. And as always, live questions are more than welcome. Please submit them through the right-hand corner. I think it's a corner chat section. Let us know if you have any specific ones. And yeah, so today's episode, as I was saying, is going to be about two things. First up, kind of like wrapping up the features on carbon fiber, like how strong it is, some of the questions that we didn't get to answer last week. And of course, reminding you guys that tomorrow we have like the in-depth webinar for carbon fiber. It's also going to be really interesting with Sean Miley, our product manager. And also, I believe it's going to be Dave Weiss, our head of engineering. So tune into that. It's going to be really interesting. And the second bit of today's episode is going to be just on part orientation, right? How do I orient my part to get the best qualities out of it? And it sort of links with the carbon fiber story in one very specific feature, which is annealing. If you haven't heard about it before, I knew the term, but I hadn't seen in action. So we'll talk about annealing and what it is, why it matters to you, should matter to you, and what do you need to make that happen, right? So with that, let's just get started with kind of a quick recap of what we talked about last week with the carbon fiber launch. Basically, looking at some of the new prints that we have. After I would say it's been about a month and a half since I had the material and the setup and been able to print carbon fiber. I think it's just I'm really surprised, especially about the layer quality of the parts. The strength of the parts is really something as well. This is just like so the part that you see here on my right is a positioning jig, right? It's just basically used to guide an element against a CNC platform. But you can see like in the blown up view, like how delicate the part is in, and also how detailed it came out of the printer, right? So carbon fiber, this specific carbon fiber, it's based on nylon 6, and it's one of the questions that I got through social media was whether this carbon fiber was a single strand or chopped carbon fiber, right? There's differences in that. To answer that question quickly, this is chopped carbon fiber. The single strand requires a very specific setup that very few printers, and most of them are dedicated. Well, actually, all of them are dedicated. That basically encapsulate a single strand of carbon fiber, as they print, and that strand follows along the same pattern of the printing process. In this case, the carbon fiber is actually present in the material itself, so throughout the material and evenly distributed. There's benefits in both, like chopped carbon fiber is going to be fairly easier to print. Single strand, because of the technical requirement of having to follow along like that, placement process, it's a little bit trickier to use, and you do need a dedicated system. And as we talked in the past, one of the biggest benefits of the method system is precisely that it's basically a platform that you can use to print many different materials, right? Right now we're talking about carbon fiber and how awesome it is. Like you print like super strong parts, easy to use, super straightforward. But you just swap the extruders, so one of these guys, and you already have a new set of materials, right? Whether you want to use, in this case with Method X, and we'll talk a little bit of materials too, but you want to use ABS now, okay, you're ready to go. You want to use PLA, you're ready to go. You want to use PVA as supports or SR30. You just need to swap the extruder and you have a brand new system with you, as opposed to having just a dedicated one that will print with just the one material. Sometimes you need that, and I can see those applications, but specifically if you're trying to get really strong parts that are just up to spec and basically do the job for you, this is just a solid option. I have one of the other parts that is kind of we've been getting a lot of good comments around it. It's a fairly complex part, right? Here it is. The propeller. I've been trying to print it in a larger scale. Right now, I haven't had the time because I've been doing a lot of testing with carbon fiber. I want to do for the next episode also like a review side by side, ABS versus carbon fiber. You know how strong they are. I do have a chart right now. Like, we could talk about the numbers and the tech specs, but I want to have like the live demo of us looking at how much weight will one part bear versus another one. But this specific part, this propeller, it's just meant to show the quality that we have going on with the material, like how smooth that part is. You can see, oh, here we go, actually on my right, how smooth the part is, right? Like the level of detail that before, here we go, before the dissolution happened and after the dissolution happened. We've been asked a lot about, do you need to use soluble supports? Can you use breakaway supports? You can use breakaway supports with carbon fiber, which is great. However, it all depends on what you're trying to do, right? Sometimes breakaway supports are something that you just won't be able to take out of the part. That's one of the limitations of many printers, that even if they offer, or if they do offer carbon fiber as a material, they won't be able to offer soluble supports with carbon fiber. Why? Because it's not that easy, right? You'd require, in this case, SR30, which is a fairly technical material. Most systems won't be able to handle it. But that's not an issue with Method, right? So that means that you can print really complex parts, which is usually the main value of using 3D printing as a process, right? You want something that it's either too hard to manufacture, or the geometry just needs it to be or requires the use of 3D printing, right? And if that's the case, then you'll probably need soluble supports to make sure that you're able to remove them once the print is done. And having said that, and as I mentioned before, we did get a lot of questions in social media too around the strength of carbon fiber. How does it compare to other materials? So I put together this quick chart, right? Two things. Really, let me move the chair here so that I can actually look at it. So two things that are like off the bat impressive about this material. And as I said, like the numbers are there. These are like the tests that we've conducted internally, and kind of like the specifications that come with the material. Just look at that heat deflection temperature. It's like 2 times as much as the next material, right? So we have PLA, PETG, ABS, nylon, and nylon carbon fiber. And you can see how it goes all the way to almost 200 degrees Celsius. So 100 degrees boiling temperature of water, 200 degrees is pretty darn hot. Like for most applications, it's going to be hard to find something that really challenges the material. That's why we have the muffler here, right? Based out of Golf GTI geometry. I like the Golf. It's a really nice car. But anyways, these are parts that are going to be able to withstand a lot of heat before deforming, right? It's just incredible, especially like for me, the reference is usually ABS, but you can see it across the board. Like nylon, PETG, they do have a little bit of higher tolerance to heat than ABS, but even against those, it's just like no contest when you put carbon fiber up to it, right? And speaking about strength, which is one of the main reasons why most people use carbon fiber as a material, right? Like whether it's layered up, which is a different application, or 3D printed, it's also because of the added strength that it will give to the parts. And in most cases, again, this chart picks those same 5 materials. So PLA, let's see, PLA, PETG, ABS, nylon, and nylon carbon fiber. And in some cases, in most of them, it's 3 times as much, the tensile strength. I am a little bit surprised actually when I see it like that about the strength of PLA. I think that has to do mostly with the fact that PLA will shatter right before it deforms, right? It's a more brittle material, but it can take a little bit of higher of a load. That's the way that I interpret that little bump in PLA. So it's at least twice as much as PLA and 3 times as strong as ABS, which is it's impressive, right? If you've ever stepped on a Lego brick made out of ABS, you know how strong those can be. And I know that's kind of a silly example, but still, the point is that this material is pretty darn strong. So whether you're using it to print like this sort of knob, kind of a valve for plumbing system, or here the receiving end of a threaded pipe, right? So here we go. This 4-way attachment with threads in here. it's just impressive, like the strength that you will get out of the material. And as I said, I will do like the quick demo. It's not going to be like super scientific because I'm still here based on my living room. But I'm going to figure out a way. If you guys have any ideas of what types of geometries you would like us to test out, do let us know in the comment section, and we'll be happy to do some testing for you guys. So yeah, impressive qualities, impressive materials, and let's see. The final bit is going to be, and this is where it sort of starts to connect with the rest of the materials and print qualities and print orientation. Annealing. We introduced with the latest release of MakerBot Print annealing in the printer. What annealing means, it's basically heating up the material once a certain industrial process has been executed on it. Think about it like, for example, with metals, right? If you think about swords, they usually reheat them up to help the metal crystallize evenly, right? So instead of having some sort of, in this case, in the 3D printing case, you have some unevenness in the layer lines, right? Because each layer will cool down a little bit, even with the heated chamber. And that's one thing that I know I keep saying about method, and it's just such a big difference between just the heated chamber versus the build plate. But what annealing will do is actually it'll keep the part warm. Well, it'll warm the part back up for a while so that the material has more time to resettle and sort of regroup layer by layer, so that you're making sure that you're giving as much an opportunity for each layer to bond with each other. And that's only possible if you have the full chamber, because we're talking here about basically an oven. And there's a similar feature that was already available before annealing that's present in the method, which is the material drying feature. So we know that method materials, are stored here in the dry sealed material base. The base themselves have humidity sensors that will let you know if there's anything going on with your materials. However, and this is what I wanted to show you today, there's a feature also not only for annealing the part once it's printed, but also to dry the material. And since that's a little bit faster, I wanted to show you guys what that looks like. So here in the printer, you would just go to Advanced, then Dry Material, and in this case, I have my PVA material. Right? So I have my bag material. Of course, always have your material in the bags, in the Mylar bags, when they are not in the dry sealed material base, because that'll keep the material dry, happy, moisture free, and just taking that material out. So let's pretend for a second that I didn't have it out, safely in the bag, and I started seeing some issues with the PVA. PVA, as you know, it's super sensitive to humidity. That's kind of its job, right? It's meant to bond with water so that it'll dissolve easily. However, it'll, because of that, absorb any water present in the environment. So if you wanted to dry up your material, what you would do is basically go to, as I said, Advanced, then Dry Materials, then it'll ask you to raise the build plate. The printer will move the build plate to a preset location that basically allows you to, and you'll see it in a second, just place one spool of filament in there, right? And what that's going to do, it's going to give you that little sort of pseudo oven to heat your material up for, depending on the material, a given amount of time. So you open the door, take your material, put it in there, close the door, and then here the printer is asking me to choose the material, like what's the material that I'm using. Here I go to PVA, and you can see that there's also a lot of presets. I know that I'm a little bit far away, so let me get the webcam a little bit closer. So I have all of the presets there, right? PLA, TUF, PVA, ABS. In this case, I want to use PVA, and it's already 45 degrees for, I think it was 12 hours. And that's about it, right? You just select the material, the drying cycle begins right here, and you're pretty much ready to go. So what the printer will do now, where am I? What the printer will do now, it's going to heat the whole chamber, make sure that it comes to an even temperature. It's not going to be hot enough for the material to start melting into itself, but it'll dry it enough. It'll make sure that the moisture is taken out of the material and that it's actually pristine and ready to use to be printed with. One of the other questions that we got about the chamber itself during the week was how safe it was, right? How yeah, based on the fact that we all know that ABS have some volatile compounds that are not safe to breathe and be around, we've actually conducted quite a few tests, and we are conducting a few more with different agencies to make sure that the material doesn't expel any sort of volatile elements when it's printing and when it's done printing. So the two ways to answer that question, which is, how do I control the particles that might be generated by the printing process is, well, first of all, when tested, and we've tested it and verified with third-party agencies as well, it's really hard to detect any compounds coming out of the printer. Why? Because the system is already enclosed. It, of course, has ventilation, but on the top part, and I'll take you to the top part for a second. So on the top part of the printer itself, it has a lot of different elements that basically keep that heat inside of the printer. Why? Because basically, the more enclosed the system is, the easier it will be to actually. I'm going to stop that now. The easier it's going to be for us to control the temperature. So it's kind of like part of the same feature set, right? In one way, we want to control the heating of the whole chamber while we're printing. Because of that, we need to enclose the system as much as possible. When we do that, we don't guarantee, but we block most of the elements from coming out. There's different things that you might want to do, keeping the printer close to, open source of air or sort of a way to filter air out. But so far, we've tested the printer, and it's just a really safe system for you guys to use in the shop, in the studio, and definitely we'll be releasing some more information around those tests in the coming weeks and months. So we covered annealing, and the second thing that I wanted to talk about, where am I, is basically now that we have so many different, give me 1 second, so many different materials added to the method platform, just go a little bit through the list that we have, right? Here we go. Okay. Here. I'm going to take you through the list and just mentioning a few of them to talk about, and let me know if you have specific questions around them. But I think it's now a good time, because of the breadth of materials that we have going on with Method, a good time to review, okay, which materials are available for which platforms, how do we cross them with the different platforms, and why would I use one material versus the other. So first of all, we got Method X and Method, both of which now can come as a carbon fiber edition. What that means is that the printer will come with a dedicated carbon fiber extruder, and that you will be able to use a carbon fiber material. Now, if you already have a Method or a Method X, you can always retrofit it. That's the beauty of the system, right? That it's always modular, and basically you're able to just get the carbon fiber extruder, put it in your existing Method and Method X, and run with it. Use the nylon carbon fiber material, and get on with working. So the carbon fiber edition, it's an edition of the same platform. It's going to have the same systems, and the biggest difference here is going to be whether you get a Method or a Method X. There is a big hardware difference between Method and Method X. It's not just the name. It's the fact that the Method X will actually be able to heat itself up way more. Now we can actually take the printer, the chamber, all the way to 110 degrees Celsius, which is pretty darn hot, right? So for most materials, and even some of the most exciting materials that are coming, as a fast follow to carbon fiber, you do need that extra set of degrees, because it's just so hard to keep them happy and prevent them from curling. So Method X is just going to give you a much bigger range of temperature as opposed to what Method offers. So Method offers up to 60 degrees Celsius. The reason is because we have a different set of heaters in the printer itself. So this is an actual hardware setting, and it does change the power requirements, right? So with Method X, I think it'll draw up to 800 watts, which is almost like a small refrigerator at times, especially when it's heating up. And Method is going to be 400 watts. Both of them will work at 120 volts, so standard outlet, but you do want to keep an eye for Method X, maybe dedicated outlet for it, just because it'll draw quite a bit of current when it's trying to heat itself up to get and to hit those temperatures. So having said that, here in our material page, that split between Method and Method X. Here is Method. These, let's see, 9 materials are what Method covers currently. And of course, with labs, you can throw at it any additional material that will be able to be printed within those 60 degrees Celsius that we have offered for Method. So we have from MakerBot the carbon fiber material, tough, nylon, PETG, PDA, PLA, and then from labs. These are materials that we have tested with labs. Of course, with labs, the whole idea is that you can use your own materials and in the same platform. But we have a few materials from labs that have already been thoroughly tested by us, and we know what the settings are. So we're able to just give you the settings and make sure that it's going to print effortlessly, almost the same way that you would expect with our MakerBot materials, right? So we have Kimbia, PETG carbon fiber, PETG ESD from Jabil, and Sev's 95A from Jabil, which is a great material. I really like it. It's like super flexible. It's really similar to a TPU. I like it better than TPU, but that's just because maybe I don't know. So far, the impression with TPUs is that they are a little bit finicky. Sev's gives you that great durometer, so it's going to be quite flexible, quite durable as well, and it prints super easily. And with Method X, you expand the amount of materials quite a bit into ABS, ASA, PCABS or polycarbonate ABS, polycarbonate ABS with fire retardant properties, SR30, which is our support material from our partner company Stratasys, Kimbia, and these are also labs material, ABS carbon fiber, DuraBio, Polymax polycarbonate, right? Most of these materials will require SR30 to print, and SR30 is just a more complex material to handle, hence why it's actually part of the Method X offering. So as you can see, like the break is, well, for me, it's like fairly straightforward, right? It depends on the materials that you're trying to use, and it's connected specifically to the print temperatures that the printer will be able to achieve. In a nutshell, I would say that, nylon carbon fiber is just like for those parts that require a lot of strength, it's just something it's impressive to work with. It's super smooth, but really strong material. Also fairly light. I need to do a comparison between the parts, but it's going to reduce somewhat the weight of your parts if using the same settings. Our tough material, as you know, we've used it in the past for many different applications. It's going to basically withstand quite a bit of mechanical, wear a little bit. That's also true, especially for nylon. So if you think about gears, something that is going to have a sustained impact that needs to withstand a sustained impact. With PETG, the material that you have in most of your water bottles, right? Really resistant to liquids, right? So great for those types of applications. PBA, the support material for most of the materials within the Method platform. PLA, super straightforward. I think we all started printing with PLA. So great for prototyping, great for the quick test, for just getting your ideas out in a physical way. And then with Method materials, we have ABS. So Lego bricks, basically most of the injection molded parts are going to be made out of ABS, super standard material, really strong, super easy to use with the Method, especially with the heated chamber. It keeps it warm and happy because ABS has quite a tendency to shrink after it's been printed just because of the thermal sensitivity that the material has. That even heated chamber is going to prevent that from happening. ASA, basically the outdoors cousin from ABS. Think about, seaboard water applications, things that are going to be outside, things that need to withstand certain UV exposure. PCABS, super strong, great for replacement parts. We've seen it used a lot in railroad application and also in transport. Overall automotive industry uses it a lot because it's a really strong material. It's super easy to injection mold, and because of the fact that most of the parts that you're trying to replace are injection molded, with 3D printing, you don't need to spend a whole lot of money in that mold to create a replacement part. SR30, the support material for all of the materials that I mentioned so far, and then the labs materials, which are, I think that require a talk on their own. Now, going to MakerBot Print. Give me 1 second. Here we go. So you've selected your material, right? You have your part. Now you want to slice it. And we talked a few times about, how do you slice your part? What are the best ways to orient your part? You know, it's going to depend a lot on the part, and that's where I would say, like, do send us parts, because we really like to see what you guys are going against and what are you trying to print. We like to help and sort of offer pointers. And in this case, I'm taking that propeller shape, right? You can imagine, and this is, I know this is kind of like basic for some of you, but I think it's important to cover the one-on-ones and the reasons why this platform makes a lot of sense, more so than others that don't offer like that true benefit of using a 3D printer, right? Which is being able to print really complex parts that require support sort of inherently, right? If you imagine, as I'm going to be printing this part, all of these extending elements, so basically the actual blades of my propeller, are going to require some support to rest up against, right? That's what I was showing. Where do I have my bar? That's what I was showing with this guy over here. It's going to need sort of that scaffolding to be able to print on top of. With most printers, you won't be able to have that soluble support, especially for more technical and technically challenging materials like ABS, in this case also nylon carbon fiber, because and that means that you cannot print such a complex part simply because you're not going to be able to remove those supports ever, right? So first off would be just to position your part, then select the materials, select the print modes, and here, it all depends on the setup that you have and the printer that you're using. We have 4 main print modes. It depends on the setup that you have, the ones that are going to be exposed, right? So we have balanced, which is kind of our default. It's going to be printing at a fair speed, 20% infill, so it's going to be fairly strong. Two shells, that means 2 layers, 2 outer layers bounding your part. Then we have our draft mode, which is going to print super fast or way faster than balanced. The main thing that changes there is actually the infill, right? It's going to reduce dramatically the infill, and it's going to try to make or to optimize for print speed. High quality mode, this is going to optimize for the outer layers without compromising the infill, right? So it's going to stay at about 20% infill, but it's going to take quite a bit longer because it's delicately putting each of the layers. I would say that most of the prints that we've seen, especially with carbon fiber, sort of blow my mind quality wise, but this is going to make it a little it's not available for, I don't think it's available for carbon fiber just yet, and it's also going to decrease the layer size to 100 microns, so it's going to be really delicate and detailed models that you will be getting out of the high quality mode. And then solid mode, as the name says, it's just going to be a chunk of plastic, a chunk of the polymer that you're using, completely solid, covered up. There's no 10% infill, 20% infill. It's just solid. It's going to try to cover all of the volume of your part with material, and that makes parts that are extremely durable, extremely strong, and super easy to use. Well, not super easy to use, but great for replacing injection molded parts, because that's kind of the goal, right? To get as close as possible to an injection molded part. And with solid mode specifically, or especially, it becomes even more critical that the material is really warm and happy throughout the printing process. Why? Because the more material you have, the more of those micro stresses and the more of that shrinkage that you will see with your parts happening as the printing process carries on. So that's an overview of it. I want to also have some time to cover some of the questions here. Let me go back to the webcam and touch on some of the questions. I know that it's been, I wanted to keep it simple, but yeah. So does the peel height determine how long my part will take to print? Yes, right? I would say that overall, focusing on how, if you had to pick a part that it's let's say like my phone, right? If you had to pick your phone here and you had to pick whether you want to print it vertically or flat against a peel plate, flat against a peel plate is always going to be faster, and it will also, I think, print better most of the time. Why? Because sometimes, if it's especially with such a thin part, you might compromise the stability of it. It all depends. It might need supports, which will add time to the part. So I would say keeping your parts as close to the peel plate is going to be better, and it's going to, specifically for reducing the print time. Is the experimental extruder, can the experimental extruder be used? Missed that part. How much of additive design involves thinking about the support of my part? That's one of the big things with having soluble supports, right? When you have soluble supports, you don't have to think about the support of the part itself. You think about it when you're ready to print, when you're about to slice a part. But the whole idea here is that I'm able to just design the part first and then decide how am I going to orient it. With previous systems, when I had the Rep Plus, I did have to think a little bit more about, well, is this going to be even possible? How am I getting the supports out of here? Can I simplify it a little bit just to make sure that the part will not require as much support? It'll be easier to print. So I would say when you have soluble supports, when you have such a system, it's not as important anymore. And that's kind of like the goal, right? That's where you want to be at. When designing a part, how important it is to think, how do you make supports easier to remove? I think, that's kind of one of the same of the previous question. It's basically using the right materials. If you have soluble supports, it's a breeze, right? Even breakaway supports, I think that these systems do a great job at it. It depends on the part, right? Breakaways will be printing faster, but I would say that for me, just soluble supports is such a game changer, especially for complex parts that you don't want to compromise on the shape, right? Will there be support for thicker filaments in the future? Not as of now. Right now, the specification for our materials is 1.75. I know that other platforms use 3 point something. The main reason why, that's my reading of it, so personal opinion here, I think that the main reason why they use thicker filament is because of the way that they are pushing the filament. They have a different system to push the filament into the extruder. The system itself is detached from the printing head, and that means that they need to push that material quite a bit far away from the extruder itself. And they need that material, because of that extended length, they need that material to be fairly stiff, hence the thickness, right? So we don't. We simply push, the extruder itself, the gear set of the extruder, I have it here, it's like 2 inches away from the nozzle, right? So you don't need that extra thickness to be able to make sure that the filament itself will flow, because it's just right there. When you have that system that's disconnected from the nozzle, yeah, you need it, but it's also, that's why one of the reasons why I don't like those systems. It adds, another element of potential failures to the print. That's my take on it. What's the challenges with using 2 types of thicknesses? Well, I've never printed with 2 different types of thicknesses in the same system. So, but I think I would say like that was kind of like my way of addressing that question. We don't offer thicker filaments because of the fact that the gear set, the actual elements pushing the material through, are really close to the nozzle. So we don't need to add that extra robustness of the material to make sure that the filament doesn't bow as you're pushing it through. Can the experimental extruder be used in support material? Not at the moment, but we're definitely, that's a great idea. It's definitely something that I think would be really interesting to look at in the past. So right now you can use experimental extruder with either extruder 1 or extruder 2 or extruder 2X. Extruder 2 dedicated for PPA, extruder 2X A is dedicated for SR30 at the moment. But it's definitely something that I think would be interesting, especially because you can think about a type of part that you wouldn't want to use, the secondary material as support. So maybe you're trying to print in 2 different materials. So think about like an overmolded part that has an element that's flexible and an element that's stiff. That would be, I think, a great application. It's not something that's possible right now. Super interesting. For the future, I know that I would be excited. The infill pattern relevance, well, right now we in MakerBot Print, and I'll just go back for that in a second, and I'll wrap with that up because it's a kind of a geeky answer to that, but it's super interesting. Why? Because we have so many different infill patterns here, and we could do just as probably a chats on all of these, why they mean. Some of them are just for fun. We have cat fill, donut fill, Hilbert fill, shark fill. These literally are going to draw little sharks inside of the part. Nobody will know them, right? Once the part is done, they'll be covered. But it's super fun to make. Like we did that. I remember when they released the donut fill that was for Simpsons Day or something like Donut Day. But it's basically like a Simpsons donut inside. It looks like it. So yeah, there's a lot of, a lot of implications in choosing different patterns. Some of these are just for fun. Some of these will actually, like for example, oops, sorry, where here we go. Some of these will actually, this linear interlevel, if you were to compare the linear versus the linear interlevel, it's going to basically, crisscross across your part, and then that's a linear one. When you do the interlevel, that's what it's going to do is, do one layer, yes, the next one it will skip that layer, and so on. So it's going to sort of create not an even pattern, which will save time. But again, this is a whole conversation that we could have in just talking about the different options that you have here. And it'll definitely change the way that your part behaves. Some of them are for fun. If you want to geek and have a part that has little sharks inside of them, go for it. It's always kind of fun. But this is also something that is going to be enclosed, trapped, and hidden inside of your part, so only you will know, about it. And with that, I'm going to wrap up. Thank you guys so much for joining us. As always, visit our site, makerbot.com/chats. Register for our newsletter. It does make a difference because it actually lets us know, what are the different questions that you guys have. How can we offer new materials? And do send us an email. Hello@MakerBot, Felipe@MakerBot, FLIPE. If you have any more questions, if there's something that you would like to know for the next episodes. And of course, our social media @MakerBot, both for Twitter and Instagram. It's always great to hear from you guys. And as always, stay safe, enjoy 3D printing, and we'll talk next time. Thank you.